Welcome to all. Today we are going to see about optical networks. In the first unit is about introduction to optical networks. Here the topics to be covered are telecommunication networks architecture, services, circuit switching and packet switching, optical networks, multiplexing techniques, second generation optical networks, optical packet switching, transmission basics, wavelength, frequencies, channel spacing, wavelength standards, optical power and loss, network evolution, non-linear effects, self-phase modulation, cross-phase modulation, four-wave mixing, solitons, components, couplers, isolators, circulators, multiplexers and filters, optical amplifiers, transmitters, detectors, switches, wavelength converters, telecommunications network architecture. In this network architecture, they are said about public networks, private networks, and exchanges. Public networks. These networks are operated by government and these networks are operated by service providers and mainly it is owned by government. Service providers or carriers provide the services. Carriers use their network to provide a variety of services to their customers. Example, telephone companies or the carriers. Today, carriers are dedicated to interconnect a number of internet service providers in order to provide a large bandwidth to other carriers. And virtual carriers provide services without owning any infrastructure. The carrier owns the facilities, for example, fiber links and equipment deployed inside the networks. Sometimes carriers can also lease the facilities from other carriers, and in return, it can offer a number of value-added services using these facilities. A local exchange carrier is one which offers services in metropolitan areas. An inter-exchange carrier is one which offers services to long-distance areas. Next, private networks. These networks are owned by companies, corporations, or individuals for their internal use. These private organizations rely on the capacity provided by the public networks to implement their own networks. Under this, local area networks, metropolitan areas can be there. Network within the buildings covering only few kilometers, that is the campus area. We call it as local area networks. Metropolitan area networks will be covering some hundreds of kilometer distance. Wide area networks that will be spanning even longer distances to several hundreds to thousands of kilometers. A nodes number that is central offices are called nodes. The nodes in the network are central offices. They are called as a point of presence. Long haul network interconnects different cities and spans hundreds thousands of kilometers between the central offices. This diagram shows the different parts of a public network. The public network can be comprised of either metropolitan, LAN, MAN, and so on. So, for example, in here we have assumed it comprises long haul inter exchange network. This is a metropolitan area network. This is central office. This is MAN, and this is individual users. Next, services. The services offered by the networks are classified as connection-oriented service and connectionless service. Connection-oriented service means that is before the data transfer is taking place, what a connection has to be established between the two parties or two users, and authentication is required. So in here there is a connection between two or more parties across an underlying network. The differences lie in the bandwidth the network is going to provide and the type of underlying network with which the connection is supported. This has a significant impact on the quality of service offered by the carriers to their customers. Connectionless services in here, authentication is not needed. Packets of the same messages are treated as different entity and it is sent in different direction, a different path, not different direction, it is sent in different path. Circuit switching and packet switching. Circuit switch network uses circuit switching. It provides circuit switch connection to its customers. A guaranteed amount of bandwidth is allocated to each connection and is available to the connection at all time once the connection is set up. So, a predetermined amount of bandwidth will be allocated to each connection as soon as the connection is set up, and throughout that time, the bandwidth will be available to this users. Once we disconnect only, the bandwidth will be got back. The sum of bandwidth of all circuits or connections on a link must be less than the link bandwidth. This example, packet switch telephone network follows the circuit switching. Circuit switching is not as but that efficient one because there is difficulty in handling the bursty data. Hmm. The intermediate nodes need uh, next is packet switching. Already we have seen what is circuit switching. Next is packet switching. Packet switch network. Here the data stream is broken up into a number of smaller packets. These packets are joined, combined or multiplexed together with other packets from other data streams inside the network. The packets are switched inside the network based on their destination address. To facilitate the switching, a packet header has to be added to the payload in each packet. So, this what is present in this header? This header carries the addressing information, for example, the destination address or the address of the next node in the path. The intermediate nodes read the header and determine where to switch the packet based on the information contained in the header. At the destination, packets belonging to a particular stream is received and the data stream is put back together. That is, they are joined. They'll be receiving the package. The order of receiving can be different, but at the receiver section, they are put in proper order. Example of this packet switch network is your internet. This internet uses a protocol known as Internet Protocol in order to route the packets from the source to their destination. Some packets sometimes it can be queued or buffered, that is stored until link becomes free. It implies that the link is already occupied and it is not available for the newly incoming packets. So when the traffic is very high, it causes the buffers to overflow. Even suppose assume the data that is coming is very large, so that the available memory or buffer is not enough to hold it. So buffer overflow can occur. When this happens, some of the packet has to be dropped from the network. Usually, a protocol, a higher layer transport protocol is used to handle this. The name of the protocol is Transmission Control Protocol. In the internet, it is used. It detects this overflow of the buffer and ensures that these packets are retransmitted so that there is no loss of data. Thank you.